students, welcome to online learning at Department of Civil Engineering. I am Archana K, Assistant Professor at Department of Civil Engineering, and I will be teaching you Fluid Mechanics and Applied Hydraulics, which is a course that is there in third semester for civil engineering students. Fluid Mechanics and Applied Hydraulics is basically a subject or a course which will teach you about basic fluids, their properties and their applications for engineering systems and engineering applications. So let us today understand what is fluid mechanics and what is the syllabus that is there for you to learn, and what are the basic properties called specific properties of fluids. That is syllabus, introduction to fluid mechanics, types of fluids and common fluids and their specific properties. So for the syllabus, for you to learn, we have various modules like module 1, 2, 3, 4, 5. And the objective is to make you understand about the basics of fluid mechanics and how a fluid will behave under rest where it is not going to move, and if it is moving, how it will behave and what are the parameters that you have to learn. And we also will learn about the dynamics of the fluids. How does it flow in a pipe? How does it flow in an open channel? And what are the machineries which we can use the water and build, like turbines and pumps. So module 1 is more relevant for you to understand because it is the introduction part of the course, and you'll be learning about the basic fluid properties and also the fluid pressure and its measurement. Coming to module 2, it deals with fluid statics where the fluid is at rest like in a dam or a reservoir, and fluid kinematics where you'll be learning about the variation in velocity, discharge and acceleration when the fluid is in motion. And module 3 is where you'll be learning about fluid dynamics. What are the forces that are going to act on the fluid when it is in motion? Especially you'll be learning about Bernoulli's equation and its application for various devices like venturi meter, orifice meter, etc. And then you'll also be learning about the pipes and the pipe flow and pipe network. Going to the module 4, you'll be learning about the introduction to the open channels, how the open channel differs from a pipe flow or a pressure flow, and you'll be trying to design, or you'll be able to design the flow under uniform condition and the open channel under non-uniform condition. And in module 5, lastly, you'll be understanding what are the hydro machineries like turbines and pumps, and we will be introduced to a few turbines like Pelton and Kiplan. So let's talk about the big question, that is, what is a fluid? The air we breathe, the water we drink and the blood that flows in our body demonstrate that there is a close dependence of our lives on fluids. And fluid is a matter that flows, that is, any matter which flows is called as a fluid. And fluids usually flow continuously, meaning which it won't start and stop immediately. It is not discrete. It flows in a continuous form. So the matter which flows is known as fluid, and we know there are 3 states of matter, that is solid, liquid and gas. Solid is the one in which molecules are packed together and there is no gap between 2 molecules. And in liquid, the molecules are a little apart and there is still an interaction, but in gas, they are very much apart and the volume is quite high. Fluids can be gases, fluids can be liquids, but not all fluids are liquids, because gases are also fluids. So what are the basic properties of solids, liquids and gases? You would have learned in your elementary or pre-university that basic properties of the matters are mass, shape, volume, the compressibility factor, the fluidity, rigidity, diffusion and the spacing of particles. So you know that you can highlight the property of fluidity. That is, when you see the fluidity for a solid, it is not possible. Solids do not flow. Then if you see for a liquid, it has the ability to flow. If you see the fluidity for a gas, it can flow. So liquids are fluids, gases are also fluids, but solids cannot be fluids because of the state of their matter. So now what is the definition of fluid mechanics. Fluid mechanics is the branch of physics which deals with the fundamental properties of fluids and their scientific applications for engineering systems and engineering developments. So fluid mechanics is divided into majorly fluid statics, fluid kinematics and fluid dynamics. Majorly we assume that fluid is in a continuum, meaning which the fluid is going to always flow from one point to another, and this expanse of flow is always a continuous one. Hence it is called as a fluid continuum. Since the fluid is always continuously flowing, it is known as a fluid continuum. And this continuum will have a boundary. It will have a fixed volume. So what are the common fluids that you all know? You can look at the picture here. We have various types of fluids in various colors. The lamp oil, the alcohol, then the vegetable oil, we have water. Then coming to the denser fluids at the bottom, you have honey, corn syrup, etc. One thing you have to observe is the denser or the heavier fluids are at the bottom and the lighter ones are at the top. So this will be one of the major properties of fluid, that is the weight or the density. So what are the other common fluids which are also gases? We have air, which is a mixture of various gases. We have helium, which is very lighter than air, and we have ozone, which is O3, and you have carbon dioxide and water vapor, which is also known as steam. So the basic fluid properties that are there for your syllabus and that you need to learn are called as specific property. Before I teach the specific property, you need to know there are other two common properties called as physical properties and chemical properties. As you all know, physical property will be the smell, the color, or something which you can see from your eyes. Chemical property will be the composition, the molecular structure, the way it interacts with other fluids or gases. So coming to the specific properties are the extensive properties of the fluid which are described with respect to their unit mass of the fluid. Unit mass is unit weight. So that is why it is called as specific properties. The specific properties which you have to learn are specific density or mass density, specific weight, specific volume and specific gravity. There are four types of specific properties, that is specific density, specific weight, specific volume and specific gravity. We'll learn all these one by one. Starting with the first one, which is known as specific density. It is the ratio of mass of the given fluid to the volume of the fluid. So that is, if you are given 1 kg of fluid and its mass is 1 liter, then 1 by 1 will be the specific density. And it is given by the symbol rho, which is a Greek letter, that is rho. Specific density is equal to mass by volume, or it is given as rho is equal to m by v, and the unit will be kg per meter cube. Kg for mass, meter cube for volume. This is the SI unit. So to give an example, if the mass of the fluid is 0.5 kg but it has a volume of 0.4 cubic meter, then the specific density will be 0.5 divided by 0.4, that is mass of 0.5 kg divided by 0.4, which will be 1.25 kg per meter cube. Now to relate and understand the matter and the specific density, we have the values of normal typical matter or liquids. We have water, which will have a value of 1000 kg per meter cube. Mercury has a specific density of 13,546 kg per meter cube, which is usually rounded off to 13,600 kg per meter cube. Air will have a density of 1.25 kg per meter cube. Please look at the values here. Water is having 1000, which will be a reference value for all the densities. So you can see that air is having 1.29, which is quite lesser than 1000, that is for water. Hence air is always lighter and it floats above the water. And then all fluids having specific gravity less than 1000 kg per meter cube, which is a reference for us, will be lighter, and anything which is having more than 1000 kg per meter cube will be heavier. The reference level here is the water. Water is considered to be a universal reference matter, especially for fluid mechanics. Water is the reference line, and the value of specific density for water is 1000 kg per meter cube. So anything any matter having the specific density less than 1000 will be lighter, more than 1000 will be heavier than water. The next specific property is, these are some of the specific densities that I have already mentioned. And then we have the next specific property, which is known as specific weight. It is represented by the small letter omega in the shape of W. It is given as a ratio of total weight of the fluid to the volume. The total weight is given as W and the volume is given as V. Hence, the unit will be, weight is given in newtons and volume will be in meter cube. So it will be Newton per meter cube. For an example, if the total weight of the fluid is 1 kg and it has the volume of 0.4 cubic meter, then specific weight will be equal to weight, that is 1 kg, and volume, that is 0.4. 1 by 0.4 will be 2.5 Newton per meter cube. So we also have another relationship. We know that weight is nothing but mass into acceleration due to gravity, that is W is equal to m into g. So if you substitute m into g here, we will have m by v, which will be the specific density rho, and into g. So the specific weight is also given as the product of specific density rho into acceleration due to gravity g. For water, the specific weight of water at 4 degrees Celsius is nothing but 9.8 kilonewton per meter cube. Please also remember that these specific properties are affected by pressure and temperature. That's why we mentioned the temperature for the water when we have to describe for specific weight of the water. So the next one is specific volume. Specific volume is the reverse of specific density. As you can recall, specific density is the ratio of mass by volume. In this case, specific volume is defined as the ratio of the volume of the fluid divided by its mass. So this symbol, the striped V, is given as the ratio of volume by mass. Volume of the given fluid divided by its mass, which is the inverse of your specific density. That's why we can write it as the specific volume is equal to 1 by rho. And the unit will be meter cube per kg. And for an example, if the volume of the fluid is 0.4 meter cubic meter and has a mass of 0.5 kg, then the specific volume will be given as 0.4 by 0.5, which will be 0.8 meter cube per kg. That will be the specific volume of the given fluid. For water, specific volume of water is given as 1 by 1000. 1000 because we already know that the density of water is 1000 kg per meter cube. Hence, the specific volume will be equal to 1 into 10 power minus 3 meter cube per kg. The last specific property is specific gravity, which is given by the symbol S. It is the ratio of specific density of any fluid to the specific density of a reference fluid. As I already have told you, the reference fluid is nothing but water. So this can be called as ratio of any fluid of the ratio of the specific density of any fluid to the ratio of specific density of water. The reference fluid will be, or the standard fluid will be, water. Since the expression is specific density upon specific density, this specific gravity will not have any unit. It is a constant. So for example, if the density of any fluid is 500 kg per meter cube and the specific density of the standard fluid, which is water for 1000 kg per meter cube, then the specific gravity S will be given as 500 for any fluid divided by for the water. So 500 by 1000 will be 0.5. Please remember that specific gravity of water is 1. So here we can understand that if the specific gravity of any fluid is less than 1, then it is lighter than water. If the specific gravity is more than 1, it is heavier than water. So what are the common values of the specific gravity that we have for the common material? Firstly, we have water, which is at the value 1. Look at blood, which is very common in all our bodies. It is at 1.05. It is slightly thicker than water. When you come to sea water, ocean water, it is slightly denser than water. So you can see it has value of 0.025. And if you want to find out what are the matters which are the fluids which are lighter than water, you have gasoline, which is at 0.7. That means it will float over water. You can also look at alcohol or ethyl alcohol at 0.79. And mercury is one of the fluid which we consider for all examples of fluid mechanics. Mercury is one of the densest fluid which is having the specific gravity of 13.6. That means if water has a density of 1, mercury will be 13.6 times heavier than water. You can also look at gold, which is in a molten form, and you can look at ice, which is 0.92, which is quite lighter than water. Air will be very much less. It is nearly 0.0013 as a specific gravity. If you want to look at some of the construction materials in civil engineering and their specific gravity, we have sand and gravel varying from 2.65 to 2.68, and we have organic soil between 1 and 2. Remember, specific gravity doesn't have any unit, it is just a constant. And silt and silty sand is ranging between 2.66 to 2.7. These are some of the common values of specific gravity. So you can see in this picture here, the one on the right column is mercury, the one on the left column is mercury, and the one on the right column is water. So here this mercury will exert a higher pressure because it is having more density. That is, the specific gravity of mercury is 13.6. The specific gravity of water is 1. Hence, this mercury will have higher weight, higher density as compared to water. To summarize the specific properties, I have tabulated all the definition, the references and the formulae. Let us learn and recall again. The first specific property is specific density. The symbol is rho, and it is defined as the ratio of mass of the fluid to the volume of the fluid. That is, rho will be equal to mass by volume. The unit is kg per meter cube, and the typical value for water is 1000 kg per meter cube. The second property is specific weight, which is given by small omega, and it is the ratio of total weight of the fluid to the volume of the fluid. That is, omega is given as weight by volume, and the unit is Newton per meter cube. For water, it is 9.807 kilonewton per meter cube. The third specific property is specific volume, which is the reverse of specific density. That is, it is the ratio of volume of the fluid to the mass of the fluid. Hence, it is given by V by M, and the unit will be meter cube per kg. The value is 1 by 1000 or 1 into 10 power minus 3 meter cube per kg. The fourth one is specific gravity, which is a ratio of density of any fluid to the density of a standard fluid, which is water. As you can recall, the density of water is 1000. So if you divide the density of any fluid by 1000, you will get the specific gravity. And the value of specific gravity for water is 1. So if the density of any fluid is less than 1000 and specific gravity is less than 1, it is lighter than water. If the specific density is more than 1000 and specific gravity is more than 1, then the fluid is heavier than water. That's all for today. Thank you.